This is SMART, the Smart Plug-in Hybrid Electric Vehicle Program. It's the United States Army initiative to develop energy-efficient grid-to-vehicle and vehicle-to-grid charging stations for Army bases in the continental United States and beyond. To achieve this, the Tank Automotive Research Development and Engineering Center, National Automotive Center, TARDEC-NAC, has partnered with the Construction Engineering Research Laboratory, the U.S. Army Corps of Engineers, and Next Energy in Detroit. Next Energy has been commissioned by TARDEC-NAC to develop and test 2 different grid-to-vehicle and vehicle-to-grid charging and discharging stations for electric-powered vehicles that can not only charge the vehicles from renewable resources such as wind and solar power, but can also discharge electricity stored in the vehicle's batteries back into the grid to help power Army installations. The technological complexity of this Next Energy project is groundbreaking, and success will mean real progress in reducing fossil fuel costs at U.S. Army bases by as much as 20% and reducing carbon as well. In Phase 1, currently underway at Next Energy, 2 different grid-to-vehicle and vehicle-to-grid charging systems were developed simultaneously to assess different technologies. One system is stationary, the other is mobile.
Next Energy became involved in this work primarily due to its previous efforts in the microgrid arena. A lot of the technologies and electrical infrastructure that were developed as part of this PHEV program were actually offshoots of the work that we had done previously under our Advanced Mobile Microgrid program. In the PHEV program that we're involved with, we not only deliver power to the vehicles, but we take power from the vehicles back to the grid or to a building or some sort of load.
The stationary system uses a DC or direct current gateway from Nextech at Next Energy in Detroit, connected to a charging station designed by Coratech Services in Royal Oak, Michigan. The DC gateway imports direct current from a variety of sources, such as Next Energy's rooftop solar array, to the charging station, which then recharges or fuels the vehicle's rechargeable batteries.
Nextech DC power gateways convert 3-phase alternating current from the grid and provide a constant regulated source of 380 volts DC to support the grid. To that, we add solar, battery, any other renewable resource you have on site. It saves energy, less diesel to transport, which is dangerous. You have less reliance on the grid, which can go down, and it improves energy security and efficiency overall.
In the field, the DC gateway could draw power from solar cells, wind turbines, biomass, and other renewable energy sources, as well as rectifying AC power from the grid into DC power for the vehicle's batteries.
This program has 2 phases, this being the Phase 1, where we prove our technology on functionality, and in Phase 2, we make it more rugged and more implemented to the military application.
From this technology, the Army will gain vital information about DC charging and discharging.
This is our charging station that we've developed for plug-in hybrid electric vehicles. What it does is it provides charging functions for the electric vehicle as well as provide data acquisition and control functions necessary for the research and development portions of the program. The units behind me are power conditioning units that were developed for the military that will allow us to charge electric vehicles using various power sources, AC and DC sources such as generators, solar power, renewable energy.
The second smart PHEV charging demonstration, developed and being tested by Next Energy, is not stationary, but is designed to be transportable and is capable of charging and discharging both direct current DC and/or alternating current AC into and out of electric vehicles.
Next Energy picked E-Trex, a Boulder, Colorado company, for this project because we have proprietary and unique power electronic technology which allows us to take energy from the grid to charge vehicle batteries and take that energy in the battery and put it back out onto the grid. The device that we installed in this Ford Escape is an integrated power electronic module that took a standalone inverter technology and standalone charger technology and integrated them into a smaller, lighter package. that would allow us to transfer power to the vehicle and energy in the vehicle back out to the grid and or any auxiliary other application.
Called the Tactical Mobile Vehicle Charging System, or TMVCS, this charging system was developed by SAIC, and the TMVCS is being tested on Next Energy's alternative fuels testing platform.
In today's world, there's a lot of interest in alternative energy and smart grids and microgrids, in the ability to efficiently use energy from a variety of sources. SAIC's had experience with interfaces, with electrical engineering, with power engineering, and that's one of the reasons that Next Energy chose us to be their partner in building this system. And this is the kind of unit, this unit that we're talking about, is exactly the kind of unit that will be needed to fit into an overall complex system.
With an Ethernet SCADA server, Next Energy gathers data every minute of every day, showing how much electricity is flowing into both systems from either renewable resources or the grid, how much electricity flows from the stems to the vehicles recharging there, and how much stored electricity on board in the vehicle's batteries is available to flow back into the grid if necessary. Two different technologies with one goal: to provide the U.S. Army and civilian vehicles with practical, affordable, grid-to-vehicle and vehicle-to-grid options using renewable resources such as wind and solar power. Phase 1, underway at Next Energy now, is monitoring the progress of both systems, the stationary Nextech Coratech solution and the transportable SAIC Tactical Mobile Vehicle Charging System. Both systems are designed to not only import energy into electric-powered vehicles, but export electricity from the vehicles as well, in order to deliver essential and low-cost electricity, often from renewable resources, to U.S. Army installations and bases. This is the SMART Plug-in Hybrid Electric Vehicle Program, PHEV Grid-to-Vehicle and Vehicle-to-Grid Test Project, finding new ways to conserve, redirect, and repurpose electricity to benefit the United States Army. Developed by Next Energy with the cooperation of the Tank Automotive Research Development and Engineering Center, National Automotive Center, or TARDAC-NAC, and the U.S. Army Corps of Engineers. To learn more, go to www.nextenergy.org.